Kubernetes and GKE Part 45. This episode has 17 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Scenario: a regional outage affects your GKE application. What should your architecture support? Here's a strong way to approach it. A resilient architecture should support multi-zone or multi-region deployment, health-based traffic routing, replicated data, automated failover, and tested runbooks. If active-active is too complex, active-passive with clear RTO or RPO may be acceptable. The answer should explain trade-offs between cost, consistency, complexity, and recovery speed. Nice. Let's continue. Question 2. How do you optimize Kubernetes cost without hurting reliability? Here's a strong way to approach it. Right-size requests. Use autoscaling. Choose suitable machine types. Remove idle workloads. Optimize logging. Use spot or preemptible nodes for fault-tolerant jobs, and separate critical from batch workloads. Keep enough headroom for reliability and scale-out delay. Cost optimization should be guided by metrics, not guesswork. Great. Moving on. Question 3. Scenario: batch jobs are starving production services in the same cluster. What would you do? Here's a strong way to approach it. Separate workloads using namespaces, quotas, priority classes, taints, node pools, and scheduling policies. Give production services higher priority and guaranteed resources. For long-term stability, run batch on dedicated node pools or separate clusters if isolation requirements are strong. Alright, next question. Question 4. What are priority classes in Kubernetes? Here's a strong way to approach it. Priority classes tell the scheduler which pods are more important. Higher priority pods can preempt lower priority pods if resources are scarce. They are useful for protecting critical workloads, but must be used carefully to avoid unnecessary disruption. Let's keep going. Question 5. Scenario: a model serving API on Kubernetes has cold start latency. How would you reduce it? Here's a strong way to approach it. Keep minimum replicas warm. Preload models during startup. Use readiness probes only after the model is ready. Optimize image size, and store models close to the cluster. For large models, consider node local caching, GPU node pools, or dedicated serving frameworks. Measure startup time and request latency separately. On to the next one. Question 6. How do you monitor ML models in production? Here's a strong way to approach it. Monitor service metrics such as latency, errors, throughput, and resource usage, plus ML metrics such as prediction distribution, feature drift, data quality, model confidence, and business outcomes. Capture prediction logs with privacy controls. Alerts should detect both system failure and model quality degradation. Good. Here's another one. Question 7. Scenario: a model's accuracy drops but infrastructure metrics look healthy. What do you investigate? Here's a strong way to approach it. Check input data quality, feature drift, label drift, upstream pipeline changes, training serving skew, model version, and business process changes. Infrastructure health does not guarantee model correctness. The fix may require retraining, rollback, feature pipeline repair, or data contract enforcement. Nice. Let's continue. Question 8. How do you design a feature store on GCP? Here's a strong way to approach it. A feature store should provide offline features for training and online features for low latency serving with consistent transformations. On GCP, possible components include BigQuery, Dataflow, Cloud Storage, Vertex AI feature store alternatives, Memoristore, or Bigtable depending on latency and scale. Governance should include ownership, freshness, lineage, access control, and quality checks. Great. Moving on. Question 9. Scenario: training and serving use different feature logic. What problem does this cause? Here's a strong way to approach it. It causes training serving skew, where the model learns from one version of features but receives different values in production. This can reduce accuracy and create hard-to-debug behavior. Use shared transformation code, feature stores, data validation, and automated tests to keep training and serving consistent. Alright, next question. Question 10. How would you explain a complex production issue in an interview? Here's a strong way to approach it. Use a structured story, context, impact, your role, investigation, mitigation, root cause, final fix, validation, and prevention. Include specific tools, metrics, trade-offs, and communication steps. A strong answer shows ownership and learning, not just technical commands. Let's keep going. Question 11. Scenario. You are asked to design a secure self-service platform for developers. What would you include? Here's a strong way to approach it. Include templates, CI or CD pipelines, Terraform modules, Kubernetes namespaces, GitOps, secrets integration, IAM automation, policy as code, observability, cost dashboards, and production readiness checks. The platform should make the secure path the easiest path. Also include documentation, support model, golden paths, and exception handling for advanced teams. On to the next one. Question 12. What is the difference between GKE Standard and GKE Autopilot, and how do you choose between them? Here's a strong way to approach it. GKE Autopilot manages nodes and many operational defaults for you, charging mainly by pod resources and reducing node management overhead. GKE Standard gives deeper control over node pools, machine types, daemon sets, networking, upgrades, GPUs, and low-level tuning. Choose Autopilot for simpler, standard workloads where managed operations and secure defaults matter most. Choose Standard when you need custom node pools, special hardware, privileged workloads, advanced networking, or tighter cost and scheduling control. Good. Here's another one. Question 13. Scenario. A GKE workload gets permission denied when accessing cloud storage. How would you debug workload identity? Here's a strong way to approach it. Verify the Kubernetes service account used by the pod, the map Google service account, and the IAM binding that allows the KSA to impersonate the GSA. Then confirm the GSA has the required cloud storage role on the right bucket or project. Check pod annotations, namespace, token projection, metadata server access, and application credentials. Useful commands include kubectl describe pod, kubectl describe service account, cloud IAM service accounts get IAM policy, and cloud storage buckets get IAM policy. Nice. Let's continue. Question 14. How would you design a production GKE platform for multiple teams? Here's a strong way to approach it. Use separate projects or clusters where hard isolation is required, and namespaces where shared cluster isolation is acceptable. Standardize node pools, labels, taints, quotas, RBAC, network policies, workload identity, secret manager integration, ingress, observability, logging, and GitOps deployment. Add guardrails with policy controllers such as Gatekeeper or Kyverno. Provide golden path templates. Define slows and runbooks, and make ownership visible through labels, dashboards, and escalation paths. Great. Moving on. Question 15. How would you compare Kubernetes Ingress, Gateway API, and Service Mesh Ingress? Here's a strong way to approach it. Ingress is the older common abstraction for HTTP routing into a cluster and is simple for standard host or path routing. Gateway API is a newer, more expressive and role-oriented model that separates infrastructure ownership from root ownership and supports richer traffic management. Service Mesh Ingress, such as IceGeo Ingress Gateway, is useful when north-south traffic should share mesh features like MTLS integration, telemetry, advanced routing, and policy. The choice depends on complexity, ownership model, and whether mesh-level traffic controls are needed. Alright, next question. Question 16. How would you observe and troubleshoot service-to-service latency in a Kubernetes service mesh? Here's a strong way to approach it. Start with golden signals, request rate, error rate, latency, and saturation for both client and server. Use mesh telemetry to identify whether latency is from the application, Envoy sidecar, retries, upstream service, DNS, connection pool, or external dependency. Correlate metrics with distributed traces and logs using trace IDs. Check virtual service retries and timeouts. Destination rule connection pools. Circuit breaking. MTLS handshake issues. Resource limits. And whether sidecar overhead is significant under load. Let's keep going. Question 17. Scenario. A GKE stateful workload loses data after a bad rollout. How would you restore safely? Here's a strong way to approach it. Avoid restoring over the live workload blindly. Freeze writes if needed. Identify the last known good backup or snapshot. Restore into an isolated namespace or cluster first. Validate data integrity and application startup. Then plan cutover or selective data repair. Check whether the workload needs application consistent backups, not only disk snapshots, and confirm the restored PVCs, stateful set identity, service DNS, secrets, and version compatibility before sending traffic back. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.